Thanks, Malcolm. Thanks, everybody, for lasting until 3:30 on a Friday afternoon. I'll try and be reasonably entertaining. Thanks also to Terry for organising this symposium. I think it's been a great success. And of course, it's not just Terry, but all his staff and indeed everyone in the centre that have generated the science we've been hearing about over the last 2 days. It's been an amazing breadth and depth of information. The good thing about being the last speaker is I get to speak with the knowledge that I've gained over the last 2 days and get to put my talk in that context. The bad thing is I have to try and think of something to say that hasn't already been said. What we've seen over the last 2 days is such a thorough expose of the issues facing coral reefs in general and the Great Barrier Reef in particular. I will do my best to try and find some slightly different perspectives on some of these same issues. So, for this audience, I'm not going to spend a great deal of time introducing the Great Barrier Reef, but there are just a few introductory comments that I want to make. I'm then going to spend a fair bit of time talking about the challenges that face the Great Barrier Reef. And there's a very real chance that at the end of that section of the talk, you're going to be feeling quite despondent. Bear with me. We will then get on to what are we going to do about those challenges, what have we been doing, and hopefully by the end of that, there will be at least a small ray of optimism. So the first thing that I really want to get very strongly across about the Great Barrier Reef, particularly when I'm talking about ecosystem-based management, is that the Great Barrier Reef is much more than just coral reefs. In fact, the strange little oblong that, or polygon that goes along the east coast there is the outline of the Great Barrier Reef Marine Park. And the squiggly black shapes within it are the coral reefs. They only take up about 7% of the area of the marine park. The light blue area is the Great Barrier Reef Lagoon. It's a relatively shallow continental shelf environment, quite strongly influenced by runoff from the land, mostly soft sediments, including sand and mud environments with bits of shoal here and there, some interesting islands with some interesting fringing reefs. But 95% of the coral reefs are in the middle blue tone. And so they're much further offshore. They're further away from the terrigenous influence of the lagoon and a very different sort of environment. Finally, the dark blue is actually not on the continental shelf. That is continental slope. So it's all water deeper than about 200 meters. Most people don't think of that sort of environment at all when they're thinking of the Great Barrier Reef, but in fact 36% of the marine park is deeper than 200 meters, and in fact the marine park goes down to almost 4,000 meters deep. So for a very long time we've known almost nothing about that deep part of the Great Barrier Reef. In the last few years we've started to get some really amazing multi-beam sonar imagery of that part, and we're finally beginning to learn at least what it looks like, if not what lives there. This is work from Robin Beeman at James Cook University. And Rob is actually beginning to fill in that gap of that 36% of the marine park that was largely unknown until a few years ago. And as you can see, it's a very complex and highly topographically complex structure. So if we stop thinking about very broad habitats for a moment and get down to the biodiversity, to a less well-educated audience than this, I would at this point start reeling off how many different species there are of different kinds of plant and animal on the reef. But the point I want to make is that while we may understand the biodiversity of the coral reefs very well, in particular the fish and the corals, to some degree invertebrate groups, to varying degrees, when we start to think about other environments on the Great Barrier Reef, even our understanding of what species are present is really quite rudimentary. When we think about the 36% of the marine park that is deeper than 200 meters, we know almost nothing. So aside from those big gaps in our knowledge of the species, there is also the issue of our lack of knowledge of biodiversity below the species level, in other words, the genetics level. And perhaps 10 or 20 years ago, we wouldn't have cared that much, but with the growing impacts of climate change, It's the genetic diversity of the Great Barrier Reef that is going to determine so much of the future of how these plants and animals adapt or not, migrate with environmental changes or not, and what the Great Barrier Reef ends up looking like. So despite being one of the best studied reef systems in the world, there are still enormous gaps in our knowledge. Lawrence put up this little cartoon to illustrate connectivity, but I want to use it to illustrate something more general than that, and that is that at the Marine Park Authority, we have focused for a very long time on biodiversity, patterns of distribution of biodiversity as tools for informing management decision making. Those are still very important. But increasingly what we are seeing is a focus on connectivity and other processes, herbivory, predation, primary production, and so on. These are very difficult things to measure and describe. They're certainly very difficult things to conserve if you're managing a marine park. But again, I think largely the increasing realization of the impacts of climate change are making us realize how important it is to understand how these processes work in the marine park and to try and protect those to make sure that the ecosystem continues to function in a healthy way. As marine park managers, we are not just here to protect environmental values, although those are paramount. We are also here to protect human values. Social, economic, and cultural values are very strong in the Great Barrier Reef. There's been a lot of talk about those over the last couple of days, so I'm not going to go into any great detail. But simply to illustrate that there is a huge complexity of human values associated with the reef that actually equals the natural complexity, and that's an important part of the mix of managing a marine park as well. So having given a brief introduction to the Great Barrier Reef, I just want to talk about some of the pressures that are on it. I've listed 5. I could probably list a couple of others if I tried, but I've tried to focus on the most significant pressures and possibly the ones that are of highest profile. And I want to say right at the outset that I haven't ordered those in any particular way. I certainly don't consider them all to be equal pressures, but I will talk about that in the coming minutes. The issue is that these pressures are, of course, affecting the biodiversity, the ecosystem function, and the human values that I spoke of over the last few minutes. And although much is made of the fact that for many of these pressures, they are much less on the Great Barrier Reef than they are for many coral reef areas elsewhere in the world, still, these are the same pressures that are degrading coral reefs everywhere in the world, and we have to bear that in mind on the Great Barrier Reef. So we've heard a lot of talk about the effects of climate change, and it's having some bizarre effects already on human society and on the natural environment, and we can expect to see more of that. Most of those effects there have already been spoken about. I just want to focus on a couple of them because they're of particular importance. So this is some of Janice's work compiling the historical record and anticipated or future predictions of temperature on the Great Barrier Reef. So we already have a demonstrated warming of reef waters. And I remember when I first started using this graph, probably about 10 years ago, I pointed out the difference between very high emission scenarios like A2 and very low emission scenarios like B1 and what they would mean for the future of the Great Barrier Reef. And at the time, I had the luxury of not being too worried because we really didn't know which of those we were tracking, but today we know we're absolutely following A2. So no matter what we do, the temperature on the Great Barrier Reef is going to go up, and it's going to go up at a faster rate than it has in recorded history, and it looks like we are heading towards the worst of those scenarios, and that's extremely important. I'll come back to that later. Of course, it's not long-term average temperature that actually does the damage to the reef. It's specific extreme events, and the issue is that as long-term averages go up, the extreme events will become more severe and more frequent. These are NOAA satellite images of sea temperature on the Great Barrier Reef during the 2002 bleaching event. And of course, we all know what happens when we see extreme events like these. And as Malcolm and Janice spoke about yesterday, it is the increasing frequency and severity of such events that concerns us. We also heard yesterday about ocean acidification and the reduction in calcification of porites on the Great Barrier Reef of 14% since 1990, we can't prove that that is purely because of acidification or temperature. Maybe it's a bit of both, but it's certainly an extremely worrying sign that the reef seems to be responding in exactly the way we would predict given impacts of climate change. It's not just about coral reefs. We have already seen on the Great Barrier Reef significant mortality events of seabird chicks and turtle eggs caused by extreme summers. Some of these species are already in decline anyway for other reasons. To have extra impacts compounded on top from climate change is not going to help at all. We saw Tropical Cyclone Hamish in March of this year, and it had an extremely unusual track for a Great Barrier Reef cyclone. Most wander around randomly in the Coral Sea for a while and then have a fairly jagged path across the continental shelf and onto land. Not only was this a very powerful and fairly large cyclone, but it was a track that really followed along one of the densest areas of reef matrix in the Great Barrier Reef. I haven't seen the statistics yet, but I would strongly suspect that this cyclone caused more damage to the reef than any other cyclone that we've recorded, certainly in a very long time. And again, if climate change is going to make events like this more frequent and or more severe, this is going to cause us a big problem. Obviously, our understanding of climate change is only just emerging. There are a wide range of other threats to the reef that we have been studying for a longer period of time, and perhaps we have a better understanding of them because they've been around for longer. A lot of these threats are not new. We have been drastically changing the nature of the Great Barrier Reef catchment for at least 150 years. And these are photos of just some of the uses that we have. This is not a modern phenomenon. We've been causing this damage for a very long time. The cumulative effect of this is that when we look at a map of land use in the catchment of the Great Barrier Reef, there are only very small areas that are actually completely natural and unimpacted. The catchment broadly is largely used predominantly for beef grazing, and then there is a narrow strip right along the coast that is a variety of different sorts of agriculture, particularly sugar. This process hasn't stopped. If we look at recent satellite images, this is my hometown of Townsville, it's still spreading. And so we have urban development as well as agricultural development. When we look at the port of Townsville, we are actually reclaiming quite rare inshore marine environments for industrial uses. Of course, the big expansion is from agricultural uses. This is the Burdekin River and its catchment. And again, in recent times, there is still strong expansion of agricultural land. And these are serious issues. When we look at what does this mean for the reef environment, and I should say that coastal development is not just about water quality, it's actually about the direct degradation of wetlands, coastal habitats, many of which are actually important for marine species. It gets back to that connectivity between habitats argument. But water quality is an extreme concern generated by our activities on the land. I'm going to show you 3 photographs of a flood plume from February 2007, and this is the area between about Hinchinbrook Island and Port Douglas on the Great Barrier Reef coast. Initially, when flood plumes start, the primary flood plume is heavily laden with sediment, nutrients, pesticides, and the waters of the flood plume are extremely turbid. As time progresses and the flood plume spreads away from its original source, the sediment drops out quite quickly, but of course the nutrients in particular are carried much greater distances, and we are even detecting biologically active levels of pesticides on mid-shelf reefs in the Great Barrier Reef. By this stage of the flood plume, a lot of the nutrients have already been turned into phytoplankton and the sediment has dropped out, so the water is less turbid. This is the stage of a flood plume where it turns bright green. And we can see that the flood plume even goes all the way through the reef matrix, out into the Coral Sea, and indeed beyond the Great Barrier Reef Marine Park itself. As rainfall patterns change under climate change, these sorts of events are probably going to get bigger. In other words, we might not have a change in the average amount of rainfall, but we are probably going to get more intense rainfall events when we get them. So these sorts of big floods that push out huge amounts of water, that take pollutants right out to the reef, will probably get more common. And of course, although there's far from a smoking gun, there is a fairly convincing argument linking crown of thorns starfish outbreaks to phytoplankton blooms associated with big floods. And when we see these huge phytoplankton blooms going right out through the matrix of the Great Barrier Reef and out into the Coral Sea, it's a real cause for concern. Fishing and hunting, again, not a new activity on the Great Barrier Reef. We've had fisheries in the Great Barrier Reef since the 19th century. And as people were talking about earlier today, we've had quite large industrial scale fisheries for pearl oysters, bêche de mer, trochus. Believe it or not, we have actually had industrial commercial exploitation of dugong and turtle. That shed in the bottom right-hand corner is part of a turtle cannery on Green Island. I don't know how many of you know Green Island. Today it's a major tourism centre. But before it was a tourism centre, it was a place where we slaughtered turtles, stuck them into tin cans and exported them. This is the Great Barrier Reef I'm talking about. The sawfish in the top right-hand corner. It's very hard to find a sawfish adjacent to the Great Barrier Reef these days. You certainly don't find them at 5 to 6 meters long the way you used to. So there is a long history of fishing and hunting in the reef, and a lot of the impacts from the fishing and hunting would have happened a long time before we had any kind of monitoring. So what sort of consequences have we seen because of this? Lawrence showed this graph earlier today. This is the population decline of dugong in the southern Great Barrier Reef. By southern, I mean south of Cooktown. The population since the 1960s has been decimated through a variety of reasons, mostly incidental capture in mesh nets, but also hunting and poaching and boat strike. The point I want to make here, yes, this is an iconic animal. It's an important part of the Great Barrier Reef's biodiversity. It is an internationally threatened species, and for all these reasons we should be concerned by this. But my concern goes to a different level. This is a herbivore. This represents tens of thousands of animals, each weighing 200 plus kilos, that should be in the ecosystem eating plants that aren't. What does this mean for the process of herbivory on the Great Barrier Reef? What does that mean for the resilience of the ecosystem in a changing climate? The short answer is we do not know. Very similar story with loggerhead turtles, but for different reasons. We've been monitoring loggerhead turtle populations since the mid-1970s, and there has been a very strong population collapse, largely driven by incidental capture in trawl nets and feral animal predation of eggs on mainland nesting beaches. And again, it's not just about the status of an iconic species. What is the role of that species in the ecosystem, and how has the functioning of the ecosystem changed because of this change in one population? Determined to put in at least a couple of good news stories, we, through whaling in largely the early 19th century, absolutely decimated the East Coast humpback whale population. And in the early 1960s, when the moratorium on whaling was called into place, since then we've seen a very strong recovery of that population. And I take great heart from this. These are long-lived animals that reach maturity after quite a long time, much like the dugong and the loggerhead turtle. And yet we see that if we can remove the pressures on a population, even an animal like this can come back. And I think that's very important for informing our thinking about the problems we face with dugong and loggerhead turtle and other animals. This is some work of Nick Graham's that Gary Russ originally brought my attention to. This is a comparison from the old zoning plan. This was work done and published in 2003. Not surprisingly, the biomass of coral trout in unfished areas is higher than in fished areas. That's been proved in many places in the Great Barrier Reef on many occasions. There's nothing particularly startling about that. Very important indicator of how much fishing pressure there is. What interests me more from this particular study were the results about prey species of coral trout. And the prey species, and Nick and his co-authors went to a great deal of trouble to make sure that they really did look at known prey species, shows the inverse relationship. Perhaps it's not a smoking gun. As a coral reef manager, Hugh, more interested in type 2 than type 1 errors, it's good enough for me. It makes me very concerned, not just about the stock of a species targeted by a fishery, but about the effects, again, on ecosystem processes, in this case predation. What does that mean for the trophic web on these coral reefs where coral trout and other fish populations are reduced? Because Lawrence spoke entirely about the zoning earlier today, I deliberately cut a lot of stuff about zoning out of this talk, but in terms of trophic cascades, resilience of reefs and so on, I would remind you of that tantalizing finding that crown of thorns starfish outbreaks are actually much more frequent on fished reefs than unfished reefs. So, some of you might have noticed that on my list of pressures on the reef at the beginning, I did not list the crown of thorns. And there's a simple reason for that. The crown of thorns is actually a natural part of the reef ecosystem. It's not an introduced species, as many people think. The question is, are the outbreaks that it undergoes periodically natural or not? And the short answer is we don't know, but there is evidence both that degraded water quality through nutrients enhancing phytoplankton productivity and through fishing are involved in increasing the frequency and severity of crown of thorns starfish outbreaks. In recorded scientific history of the reef, crown of thorns are by far the greatest source of mortality for hard corals, more than flooding, more than pollution, more than coral bleaching. If we want to do something about improving the resilience of at least hard coral communities and those other animals that depend on them in the face of climate change, you couldn't do much better than put at least a big dent in the frequency and severity of crown of thorns starfish outbreaks. But on their own, they're not the root cause of the problem. Tourism, thankfully, has evolved quite a lot on the Great Barrier Reef. There are activities that were conducted in the early days that we would consider simply socially unacceptable now, and I think that's a good thing. There have been times when tourism has expanded hugely and quickly on the Great Barrier Reef and actually caused quite a lot of concern as a major environmental impact. And certainly in other parts of the world, unregulated, unmanaged tourism is actually quite a significant impact. So on the reef, we've only been monitoring tourist numbers since about 1994. There's been a steady increase, but in recent years, that has plateaued at somewhere around 2 million visitors per year. We have not put the data from 2009 on the graph yet, but we have indications that with the global financial crisis, perhaps not surprisingly, tourism is going down. Not drastically, but a little bit. But still, there are an awful lot of people visiting the reef every year. And I would draw your attention to the fact that there's probably twice as many recreational visits to the reef as there are tourism visits, and we don't actually manage those. Okay, this is the part of the talk where hopefully your despondency has reached its peak, and I can now start to point out that there are things we can do and have been doing about these problems. We've seen a version of this conceptual diagram earlier today, but there's a very important distinction between what we saw earlier and how I'm going to present it. Of course, we expect reef condition in the Great Barrier Reef to vary. That goes without saying. Even under completely natural conditions, the condition of the reef would vary. At the present day, I would suggest that we are already seeing a Great Barrier Reef that is degraded through historical fishing, historical degraded water quality, and increasingly from the impacts of climate change. So the Great Barrier Reef already is not what it once was. It certainly is not pristine. Unfortunately, it's almost undoubtedly going to get worse. There seems to be no strategy or scenario in which it doesn't. So we are firmly aware that that is what the future is going to bring. But it seems that there are two choices. In one scenario, the Great Barrier Reef loses condition and is degraded, but it bottoms out and stabilizes and recovers. In the other scenario, it does not bottom out until it reaches rock bottom, and then it stabilizes in a very highly degraded state with no social and economic values, and it stays that way for a very long time. Not surprisingly, the Great Barrier Reef Marine Park Authority is quite interested in trying to deliver the first of those scenarios. So what is going to make the difference between scenario A and scenario B? Well, the first and most important, without question, is climate change. There is no doubt that this is the greatest long-term threat to the reef, and the greatest determinant of the future condition of the reef will be the rate and magnitude of climate change. So, message number one is we have got to get that under control. And as I said before, our current track along the highest of the IPC scenarios is not the way to go. Speaking as someone who works for an agency that manages a marine park at a local scale, albeit a very big marine park at a very big local scale, it's still a local coral reef management issue. There's nothing we can do about climate change other than educate people. But we can focus on the resilience of the system. So somewhere, as the reef degrades, there is a resilience threshold, below which it will probably collapse, and from which it probably will not recover. The biggest problem with resilience thresholds is the only real way to find them is to cross them. And until you've crossed it, you don't know where it is. So you've got to manage in a precautionary way and not wait till you think you're close to the threshold and then do something, but start now and do everything you can to lower that threshold and thereby increase the resilience of the reef. The key things that we need to focus on are protecting our biodiversity, improving our water quality, and making sure that uses of the reef, such as fishing and tourism, are sustainable. This is where we have to focus our efforts on a local scale. I really want to press home one very important thing. Increasing the resilience of the reef will buy us time for mitigation efforts to have an effect, but they will not make the reef climate change proof. So these are not alternative options as strategies. They are both absolutely essential. A lot of people struggle with that sort of resilience argument and how does that relate to coral health. And perhaps this isn't necessary for this audience, but I usually put it into a much simpler context. These are exactly the same sorts of decisions that we all make about our own health all day, every day. We all know that if we lead healthy lifestyles, exercise, don't drink too much, don't smoke, and so on, then we will be healthier and more resistant to a disease if we catch one. It's exactly the same for the reef. So we're trying to deliver a future for the reef that looks like this, and we are trying to avoid the future for the reef that looks like this. It's a bit silly, but it really is that simple, and it does help to get the message across to people. So, once we understand that need for that ecosystem-based approach, in other words, when we talk about the resilience of the reef, it's no good looking at one thing. We have got to focus on the suite of pressures affecting the reef in exactly the same way that it's great if I don't smoke, but if I drink 2 bottles of scotch every night, I'm probably not going to be that healthy. It needs to be a holistic ecosystem-based approach. I'm going to go through the range of things that we've been looking at and dealing with. I'm sure that for this audience, and in particular with the range of talks that we've already heard over the last couple of days, I don't need to talk about the zoning plan anymore, but clearly it is a central pillar of the Great Barrier Reef Marine Park Authority's approach to ecosystem-based management. I don't think I'll say anything more than that. Lawrence showed this graph as well, but I'm going to use it for a slightly different purpose. Lawrence pointed out the catastrophic effect of introducing the zoning plan on recreational fishing. So this is actually a graph of the number of recreational vessels registered in the Great Barrier Reef catchment. It's nice that we were successful in not damaging recreational use of the marine park, as much as this is an indicator of that, and I think it's a reasonable indicator. But my point is not that, but is look at the inexorable growth. It doesn't stop. The global financial crisis is actually just sort of visible near the top right-hand corner, but didn't affect people for very long, and they went straight back into buying and registering new boats again. This is a real issue for us. So the zoning plan is a great thing, but I guess my point is that it might have stopped take in certain areas, but it did not stop increasing pressure in the other areas. Tourism. As I mentioned, in many parts of the world, tourism is a very serious impact on coral reefs. I believe that it could, in principle, be a very serious impact in the Great Barrier Reef if it wasn't well controlled. We have 900 plus operators who take around about 2 million people per year. But not only is the industry very tightly managed through zoning, regulations, permits, it's also very much the case that the tourism industry, for the most part, work in partnership with the Marine Park Authority. They're not silly. They know that their industry is very much reliant on a healthy, beautiful, exciting reef to show people. And so they're interested in helping to maintain that. And so the impacts of tourism are very well controlled. And in fact, the tourism industry engage with marine park management in partnerships, including monitoring programs like the Eye on the Reef program, and high standard operators who receive eco accreditation for going above and beyond the call of duty and environmental sustainability. So I really do believe that the Great Barrier Reef probably has one of the best managed coral reef tourism industries in the world. Improving water quality, we've been working on this for quite a while. The two great milestones in terms of government commitment to dealing with the issue are an agreement between the Commonwealth and state governments, the Queensland government in 2003, and then the Commonwealth government's plan in 2008. I'd like to say we've spent more than 150 years creating the problem of our degraded catchments and their associated degraded water quality. It's not going to be a problem we can fix overnight, but the progress is really there and it's strong. A lot of farmers are very interested and already implementing much better land use practices. Not everybody, but change never happens in a population of people simultaneously. It's about maintaining awareness and keeping the progress going. And I'm quite optimistic that we can do a lot to improve the water quality of the Great Barrier Reef. And as Ian alluded to in his talk this afternoon, there is clear scientific evidence that that will have an effect on the resilience of the marine park to climate change. I must point out that we do not manage the marine park in isolation, so I'm not here just to talk about what Gabrumpa does. I'm talking about actions in general, and fishing is not managed by the Great Barrier Reef Marine Park Authority, it's managed by the Queensland Government. Obviously the zoning plan affects fishing, but actual fisheries management is conducted by the Queensland Government. And there have been great steps forward over the last decade or so that have fixed up many of the worst sustainability problems with fisheries in the Great Barrier Reef. I'm not going to claim that it's perfect. I think there's still room for improvement and progress that needs to be made, but I think we must give credit where it's due and take heart from the fact that we have successfully fixed some of the problems that we've had. And I think that's good news. We need more of it, but at least we've demonstrated that we can be successful. In particular, when we think about ecosystem-based management, it's great to have conservation planning like the zoning plan and fisheries management, but the two have to talk to each other. And this is probably one of the greatest examples of that. This is the total catch from the coral reef finfish fishery, so this includes coral trout, red-throat emperor, and so on. And from the late 1980s, those data were showing an increasing, steadily increasing catch in that fishery. In 2004, when we brought in the new zoning plan, and of course the zoning plan closed a lot of areas to fishing, the Queensland Government also brought in a new fisheries management plan, which for the first time in that fishery capped the catch at about 3,000 tonnes. And I don't know if you can see a horizontal green line at 3,000 tonnes from 2004 onwards. even though the catch of that fishery hasn't reached that total allowable catch since then, the point is that there is now a complementary management mechanism to go with the zoning to control catch as well as the footprint of the fishery. One final thought. You might notice that none of the science I talked about in this entire talk is my science. I don't do science. I talk to people like you, I listen to your presentations, I read your papers, and I glean from those the information that is needed to manage marine parks, and I talk to you guys about how we manage marine parks. And the successful management of coral reefs and the securing of future healthy coral reefs really does have to be a partnership between lots of people, between government and industry, NGOs, but an absolutely critical partnership is the partnership between natural resource managers like myself and scientists like most of you. So I would like to thank you for the work that you do. I would like to thank you for these 2 days where we've been able to exchange some information. I would like to thank you for the opportunity to speak to you about the challenges that we are facing in the Great Barrier Reef. And hopefully not too many more wheels will fall off and we will be able to keep steering a future course